So in the question, what we are given is, we are given nums. It is an integer array, and we have threshold as 6. So what we want to do is, we want to find such a divisor that we take the divisor and we divide every number in the nums by this particular divisor. Let's say 1 by 2, 1 by k, 2 by k, 5 by k, and 9 by k. And you sum them up. Okay, that means you add them up, and whatever result you get, let's call it alpha for now. The value of alpha should be less than or equal to the threshold. Okay, let's call this threshold t. So alpha should be less than or equal to t. That is what we want to find. So let's take this example. We have nums as 1, 2, 5, 9 and threshold as 6. So what should be the value of result? So let's call that result by alpha, and we have to divide every number by k. So let's take nums, each number, and divide it by k. And we have to also sum each number. Whatever the result we get, we have to sum them up. So 2 by k plus 5 by k plus 9 by k. Okay, and this alpha should be less than or equal to the threshold, right? So that is what we want to find. This alpha needs to be less than or equal to the threshold t. If that is the case, then we return the value of that particular k. So let's try run for k is equal to 1. K is equal to 1. In that case, the alpha is going to be 1 by 1, 2 by 1, 5 by 1, plus 9 by 1. The alpha is going to be, if you sum them up, it will be 17. So 17 is clearly more than threshold. 17 is clearly more than threshold. So we cannot consider this k. Okay. So this k we cannot consider. But let's say k is 2. Then the alpha is going to be 1 by 2, 2 by 2, 5 by 2, and 9 by 2. And we have to take the ceil value of each of them. So if you take ceil value of each of them, then the alpha is going to be, this is going to be 1 plus 1 plus 3 plus 5. Okay, it's going to be 8, 9, 10. Alpha is going to be 10. So again, it is more than threshold. We cannot take this value. K is equal to 3. Alpha is going to be 1 by 3 plus 2 by 3 plus 5 by 3 plus 9 by 3. Alpha is going to be, again we take the ceil value of it. This is going to be 1 plus 1 plus 2 plus 3. So the alpha in this case is going to be 5, 6, 7. So k is equal to 3 does not work. Let's try k is equal to 4. Alpha is equal to 1 by 4 plus 2 by 4 plus 5 by 4, 9 by 4. Alpha is going to be 1 plus 1 plus 2 plus 3. Again, it's same. The alpha is going to be 7. Let's try k as 5. So the alpha is going to be 1 by 4, 1 by 5 actually, 2 by 5, 5 by 5 plus 9 by 5. The alpha is going to be 1 plus 1 plus 1. In this case, it is going to be 2. So the value of alpha is 5. And this is our answer, since alpha as 5 is less than equal to threshold. What is the value of threshold we have? We have threshold value as 6. So 5 is less than or equal to 6, true. Okay, so we return this as the answer. So if you see, what we have done is, we are actually checking for every kth value. K is equal to 1, k is equal to 2, k is equal to 3, k is equal to 4. But this is not an efficient method, and that is the reason why we require binary search. Okay, so how does binary search come into play? We can do it linearly, but it is going to take a lot of time. So instead of, what we can do is, we can draw a number line. So what is the starting value of it? The starting value that you can think of is, let's say, you try to divide a number x by k. Okay, but you cannot divide it by 0, right? So x by 0 will give you some problem, right? So the value should be greater than 0. So we set the starting index as 1. And what about the ending index? What you can do is you can think in terms of seal. So seal of 0.33 is also 1. That means seal of 1 by 3 is 1, right? That means if you have a number, let's say 1 by x, the seal is always going to be 1. Okay, so keeping that in mind, dividing it by 1000 or more than that is always going to give you a seal of 1. Okay, so if that much is clear, then let's think of in terms of an array 2, 3, 8. Okay, if you have number as 9 or number as 90 or number as 900, it is not going to matter us, because if you take seal of this and this, if you take seal of 8 by that 900, it is always going to be 1, and 90 as well, it's going to be 1. Okay, and 9 also, it's going to be 1. So the seal value actually determines the what value we are going to get, right? So in that case, what we can do is we can limit this to 8. That is the maximum value in the array. Why? Because seal of 8 by 8 is going to be 1, right? And after that, anything you do, it's still going to be 1. So that's why I'm going to limit it to the max in the array. I'm just calling it max in the array. So let's take another example, 2, 4, 6, 8, 10, and let's call the threshold as 8. Okay, and we want to find k such that adding dividing all the numbers and adding them up will give the value less than threshold. Okay, so let's draw the number line again. This is the starting index, this is the ending index. The starting divisor of this number is going to be 1, ending is going to be 10. That is the maximum element in the array. Let's find mid. Mid is going to be s plus e by 2. This is going to be 1 plus 10 by 2 is going to be 5. Okay, let's try it for 5. Will we able to find the answer if we use 5? So let's divide all the numbers by 5. 2 by 5 plus 4 by 5 plus 6 by 5 plus 8 by 5 plus 10 by 5. We get 1 plus 1 plus 2 plus 2 plus 2. So if we have value as 5, we get answer as 6, 8. That is 8. So clearly the threshold is 8, and the value we are getting of alpha, if we consider the number 5, that is 8. So this is a valid answer. So this mid as 8 is a valid answer. No. The mid as 5 is the valid answer. Okay. So what we can do is any values other on the right side of the mid can be the answer, but we want the lowest answer. So we can eliminate the right side. We can place the end pointer on the mid itself, saying that this is the answer, but maybe we can find a better answer using binary search. Okay, we find mid again, plus 5 by 2, we get 3. This is where the mid is pointing. Let's try to do the run on 3. Okay, so this is going to be 2 by 3 plus 4 by 3 plus 6 by 3 plus 8 by 3 plus 10 by 3. We get as 1, 1, 1, 2, 2, 3, and 10 by 3 is 3, 4. It is going to be 4. The seal value is going to be 4. The value of this is going to be 3. So if you add them up, we get 7, 8, 9, 10, 11, 12. So this is clearly not going to work since the alpha that we are getting, the result that we are getting is 12 and the threshold we have set is 8. So this is not going to work. So the value of mid as 3 is not going to work. Okay. So any values less than this is not also not going to work and the mid is also not going to work. So we remove them out. Okay. And we set the starting index to mid plus 1. That is going to be 4. Okay. We calculate mid again. 4 plus 5 by 2 is going to be 9 by 2 is going to be 4. Let's try just write it on 4. 2 by 4 plus 4 by 4 plus 6 by 4 plus 8 by 4 plus 10 by 4. We get all the ceiling values. We get answer as 1, 1 plus 2 plus 2 plus 3. So this is 5, 6, 7, 8 and 9. So the alpha we are getting is 9. So again 9 is more than the threshold value. So we cannot consider this as the answer. So we need to move the starting index to mid plus 1. So mid was pointing at the same point. We need to move it to mid plus 1. The starting point we need to move to mid plus 1. So mid is pointing at S. So the mid is going so the S is going to move to mid plus 1, that is here. Okay. And the point where it reaches, where this ending pointer and the starting pointer are pointing at the same point, that is this, we're going to stop the search and return as end pointer as the answer. Okay, that the value of k as 5 is the least value that satisfies the condition. Okay, so that is it for the explanation part. Let's move to the code and finish this question off. Let's go to the code. We set the starting index. We do the starting index as 1. So this is the minimum value that we want to divide. The ending point is going to be the max element of the nums. Okay, we perform a while for loop. Int I is equal to 0, I less than nums dot I less than e. It is going to be I is equal to e, I plus plus. Okay, and if you are able to divide and we get the sum divisor get sum divisor. Okay, we call this function get sum divisor. We pass the nums, we pass the threshold value as it is, and we pass the k. Okay, in this case k is going to be I. If this number is less than or equal to threshold, then we are going to return this as the answer. Okay, otherwise we are going to return e as the answer at the end. So let's write this functions. Int get sum divisor, copy this out, and we pass k. Okay, the value that we are going to divide everything by. Is we have to write int, or let's say sum as 0, and we have to divide the nums by k. So for auto index num in nums, sum plus equal num by k, and if num mod k is not equal to 0, that means it is even further divisible, and since we are taking ceil value, that's equal 1. Okay, whatever sum we get, we're going to return this, return sum. Let's try to run this code. K threshold k, and we are passing it as a threshold, right? So we can perform this check here. Okay, sum is less than equal to threshold, we get the answer as boolean. So let's run this out. Okay, it is accepted. Let's try to submit this out. Since this is a linear solution, we'll optimize it later. So if it works, it might give us TLE. Let's see. Yeah, TLE, right? So clearly this works, but gives us TLE. So let's perform the same operation using binary search. While s is less than equal to e, mid or possible, k is equal to s plus e minus s by 2, and we're going to check if we can divide this using possible k. Okay. If we are able to divide it using the possible k, this is going to be the answer. Otherwise, we go, if we're able to divide, we store this as the answer. Otherwise, we are not able to divide the number by this possible k. So the k value should be larger. Okay, that means s is going to be mid plus 1. And at the end, we return e. Let's run this code out. End is equal to mid. It is not mid, it is possible k. Okay, let's run this code out. It's accepted. Let's submit this out. Yeah, so it works. It beats 54%. So yeah, that is it for the video. See you guys in the next one. Bye.